welcome back. In example 4, we want to decide if each of these statements is true or false. So looking at number 1, the cosine of 2 times 20 degrees, is that equivalent to 2 cosine squared of 40 degrees minus 1? So when we look at the double angle identities for cosine, which is what we have here, a double angle, 2 times 20 degrees, and it looks like we're using the second version of that identity, the 2 cosine squared of the angle minus 1. We've got 2 cosine squared of 40 degrees minus 1, but the angle A is, notice in the front part of the identity, cosine of 2A, that's cosine of 2 times 20. So the A here is 20, which means that 40 degrees should be a 20 degrees. So 2 cosine squared of 20 degrees minus 1 would be the correct version of this identity, making number 1 false. Okay, in number 2, we're evaluating the cosine of 70 degrees rather, and cosine squared 35 degrees minus sine squared 35 degrees. That would be looking at this version of the double angle identity for cosine, and that's cosine squared A minus sine squared A. Half of 70 would be 35 degrees. So this would be written as 2 times cosine of 2 times 35 degrees. And that means the A is 35. So this would be cosine squared A minus sine squared A, which matches the identity, making this a true statement. Okay, now in number 3, tangent of 140 degrees over 2, that would be a half angle identity where the A is 140 degrees. And the other side is a not as common version of the half angle identity for tangent. It's not one that we have listed here, but it is a form of the identity. When you see one side equal to another in your statement and you can't tell if it's an identity that you know or not, remember you can always put that in your calculator or Desmos by typing the left hand in Y1, the right hand side in Y2, and comparing the graphs or the table of ordered pairs to see if they are equivalent. So if this is tangent of 140 divided by 2, we're going to compare that to the negative square root of the quantity 1 minus cosine of 140 over 1 plus the cosine of 140. Okay, and we're going to make sure that we're in degree mode since we're working in degrees. And remember, zoom trig, zoom number 7 is a good place to start. And we can see that we have a straight line up here, a straight line down here. They don't match, but they look like they're equidistant from the center. So if I go to my table and I compare these ordered pairs, notice they're the same magnitude but the opposite sign. And so that means that this should not be a negative, right? If it were a positive, then this would be an identity. And I can verify that then by going down here and removing that negative. Then compare my table and I can see that it's always equivalent. Okay, so this would be false because we have the wrong sign.